Welcome to the Ground Control 1.8 meter fixed satellite system installation video. Each of these complete systems will ship with 8 boxed components. They are as numbered: the azimuth and elevation mount with hardware, the dish arm and feed horn assembly, 300 feet of Belden RG6 coax cable, the iDirect satellite modem, the buck radio or transmitter, the LNB receiver, the 1.8 meter dish itself, and a non-penetrating roof mount. Ground Control also provides a tool bag that includes all of the specialized tools and supplies used in this installation video. The first step is the construction of the non-pen mount. A location should have been selected for installation so that there is clear line of sight to the orbiting satellite with no obstructions. Hardware for the non-pen mount is located in a bag inside of the mast pipe. Place the bag contents in a box so that no pieces are lost. Each of the 4 legs of the non-pen are built from 5 galvanized steel frames that are fastened together as shown. The fasteners used are 3/8 inch by 1 inch bolts with lock washers and nuts. At this stage, the bolts are not tightened more than finger tight so that pieces go together easily later on. These legs are designed to hold concrete blocks or other heavy ballast that keeps the system anchored in heavy winds. The next step is to take the one-piece center mast and position it between the 4 assembled legs. The legs will bolt to the bottom of the mast with 8 1/2 inch by 2 1/4 inch bolts with lock washers and nuts. This job may require 2 individuals, one to help align the bolt holes of the mast with the legs. Each of the bolts are finger tightened. Once all 8 bolts are in place, they are fully tightened with a ratchet wrench. There are 4 cross struts that stabilize the legs to the mast. Each strut uses 2 1/2 inch by 1 1/4 inch bolts with lock washers and nuts. Once all 4 struts are in place, they are fully tightened. In this demonstration, concrete blocks are used as ballast. A block is placed inside the rails to expand the rails to the correct width. The 8 bolts for each leg are tightened in this fashion, which complete the non-pen assembly. The dish mounting assembly box contains all brackets and hardware to mount the 1.8 meter reflector onto the non-pen mount. The mast mount has 8 bolts that are loosened so that the mount may fit over the mast. Make sure all bolts are loosened so the mast can slide past each of the bolts as shown. Slightly loosen the larger azimuth pivot bolt located at the top of the mount, and then remove the azimuth fine-tune limiting bracket. Once removed, the azimuth may freely rotate. Place the azimuth limiting bracket on the end of the long threaded azimuth adjustment bolt as shown, and then place it back in the hole it was removed from earlier. Position the limiter a few inches from the end of the threaded bolt. Later, adjustments will be made to allow free travel in either direction when pointing the satellite system. The reflector mount may now be secured to the mast mount. Remove the single bolt from the center of the mount, and then position it as shown to the mast mount. Insert the bolt into the same hole it was just removed from, and then finger tighten the nut against the lock washer and flat washer. The elevation fine adjust limiting bracket will be secured to the mast mount by first removing the bolt from the bracket and positioned as shown. Use the same bolt that was removed to fasten the system into place. Do not tighten more than finger tight at this point. For an easier installation of the dish to the dish mount, tilt back the mount as shown. Finger tighten the bottom bolt of the elevation fine adjust. This is one of the 2 mounting brackets used to secure the top and bottom of the dish to the mount. Fastening hardware is included in the box. In this case, a set of 2 1/2 inch by 1 1/2 inch carriage bolts with 4 washers, lock washers, and nuts are used for each bracket. Finger tighten the bracket into place. To avoid upside down placement, note the 8 bolt hole positions at the ends of the 2 brackets. Carefully remove the 1.8 meter reflector from its box. 3 individuals may be required for this process. Locate the bottom of the dish by locating the 3 edge holes. The dish bottom is the center hole. The reflector mounting bolts come in 2 lengths, 4.5 inch and 5 inches. The longer bolts go at the very top and very bottom of the dish. Place 2 5-inch bolts at the top 2 bolt holes as shown. Note that washers are not used on the face side of the reflector. Position bolts are helpful to hold the dish into place while the other bolts are inserted. A third individual is helpful because 2 may hold the dish while a third places the bolts. 3/8 inch nuts with lock washers and washer secure the bolts. All bolts and nuts may be fully tightened at this point. Use an open-end wrench to secure the bolts on the dish face. The next process is the placement of the dish arms that hold the radio in place in front of the dish. Equipment and hardware is contained within one of the boxes. Dish arm hardware includes 3 5/16 inch bolts that are 3 3/4 inches long with washers, lock washers, and nuts. Take one of the side arms and position it into place. Lightly secure the nut on the bolt. Note how loose the arm hangs so that it does not bend under its own weight. Duplicate the process on the other side. The center radio arm is also secured to the dish with a single bolt. Finger tighten it into place. When done, the radio arm will appear as shown, holding its own weight. Now secure the 2 side arms to the radio arm using a single bolt. This is a 5/16 by 2.5 inch bolt with 2 washers, a lock washer, and a nut. Once the second side arm is positioned, tighten the bolt into place. You will note the ends of the side arms have a 45-degree angle flare. If they do not fit to the sides of the radio arm as shown, they are backward and should be swapped with each other. Tighten all bolts and nuts to complete this subassembly. The assembly of the satellite radio should be done inside in a clean and dry area. The first component is the feed horn, which is already attached to the waveguide tubes. Keep the bubble wrap attached to protect the feed horn during this setup process. The number 6 socket cap screws attached to the waveguide must be removed. Be careful not to lose the position of the puck-sized mounting plate. These cap screws will be replaced with slightly longer M4 25mm socket cap screws. Assemble each cap screw with a star washer first, and then a flat washer. When done, you will have 4 sets ready to go. Slide out the old cap screws one at a time and insert the new screw. When done, the waveguide is ready to connect to the transmitter. The transmitter, or buck, is rated by wattage. In this case, the transmitter is a 4-watt buck. To prep it for connecting to the waveguide, locate the small hardware packet and remove the O-ring. The O-ring is positioned in the circular channel on the buck. Be careful to avoid inserting anything inside of the opening. Included with the radio hardware are 2 grease capsules. Carefully open a grease capsule and coat the O-ring on the transmitter. The grease helps to create a watertight seal on the O-ring. Use a finger to spread the grease evenly, avoiding the transmitter opening. Now position the waveguide onto the transmitter so that the rectangular openings of each align to each other. Finger tighten the screws into place. Take your time to avoid binding. The Allen wrench is used for the final tightening turns. Evenly tighten each of the 4 bolts to create a good seal. Next, locate the LNB, or low noise block down converter, which is the receiver portion of the radio assembly. Like the transmitter, an O-ring will be used. Position it into place. Again, use the grease capsule to grease the O-ring. Use a finger and avoid touching the LNB opening. Use the included M4 10mm hex cap screws with a Phillips screwdriver to fasten the LNB to the waveguide. Make sure to align the rectangular opening of the waveguide to the LNB. Note that like the transmitter, the LNB can be positioned in any orientation as long as the rectangular openings align. Avoid binding by slowly screwing in all screws at the same time. The radio assembly is now ready to be mounted. Remove the bubble wrap from the feed horn and position the radio onto the dish arms as shown. Hardware used to secure the feed horn in place uses two 1/4" by 1" bolts with washers, lock washers and nuts, along with a small brass collar. Hold the weight of the radio while the bolts and brass collar are dropped into place. Finger tighten the collar into place. A slightly larger brass collar assembly is used to secure the waveguide near the transmitter. Finger tighten these bolts as well. The collar should both be tight enough so that the radio can be rotated or skewed by hand and hold its position anywhere. The SuperBuddy Satellite Finder is an excellent tool for any satellite installation. It can find the azimuth, elevation, and skew angles if the GPS coordinates are known along with the satellite to be pointed at. The customer information sheet from Ground Control provides specific information required for each installation. Information such as the satellite name, which in this demonstration is G18 or Galaxy 18. You will also need to know the receiver LNB polarity, which is vertical in this case. Use the right or left arrow keys to scroll through the list of satellites to find Galaxy 18. Once found, use the up or down arrow keys to select vertical or horizontal receive polarity. VT stands for vertical. There are usually multiple transponders with vertical or horizontal polarity, and selecting any one of them should almost always be acceptable. Now press the zip key and enter in the GPS coordinates. GPS readings should always be in decimal. In this example, the installation location is 35.50 degrees latitude by minus 120.70 degrees longitude. Positive latitudes are always north of the equator, and negative latitudes are always south of the equator. Longitudes use the prime meridian to divide the Earth. Positive longitudes are on the east hemisphere, and negative longitudes are on the west hemisphere. Use the keypad to enter in latitude, and then press the Enter key. The cursor will drop to the longitude automatically. For a negative number, press the minus key first, and then press the Enter key to complete the calculation. The SuperBuddy shows both true azimuth and magnetic azimuth. Since you will be using a compass to find the satellite, magnetic azimuth is preferred. Write down the GPS coordinates, magnetic azimuth, and the elevation and skew angles on the installer sheet. Use a compass a few feet away from the dish to find the azimuth direction. Loosen the mount bolt so that it can freely rotate to an approximate azimuth location. Now fully tighten all 8 of the mount bolts that secure it to the mast. Make sure the mount nuts are secured against the mount to keep the bolts from becoming loose over time. An inclinometer is a handy tool used to show the elevation angle of the satellite. On this 1.8 meter dish, the inclinometer is positioned on the bottom of the mounting arm as shown. Why the inclinometer is used for a reading at that specific location is because it avoids having to calculate in an elevation offset angle. To understand this, it can be visualized by the angle of the satellite transmission and the angle of the radio transmission. The difference between these two angles is the elevation offset angle. On this dish, the lower bracket is perpendicular to the satellite angle, so when the inclinometer is placed there, the actual elevation angle is shown without the need to add the offset angle. The elevation of the dish is adjusted skyward to roughly 48.7 degrees. You may wish to use the inclinometer to set the dish elevation slightly lower or higher in the sky than you expect the satellite to be. Next, we need to orient the radio to specifications. In this position, the radio is set for horizontal receive, vertical transmit, and in this position, it is set for vertical receive, horizontal transmit. The customer sheet shows vertical receive, horizontal transmit. The SuperBuddy also showed a polar offset of plus 3.2 degrees. To adjust the polar offset, position the inclinometer on the side of the transmitter and turn it clockwise 3.2 degrees from 0 for a positive polar offset. You would rotate the transmitter counterclockwise from 0 if the polar offset was a negative number. Now, with all 3 axes approximately set, the SuperBuddy can be used to find the satellite signal. You can use a short 10-foot length of RG6 coax cable to connect the SuperBuddy to the LNB receiver of the satellite radio. Turn on the SuperBuddy and scroll to the satellite to be connected to, which was Galaxy 18. Also, make sure to set the SuperBuddy to vertical receive, which was done earlier. Position it to rest on the mount so that you can view the display. The slow beeping will increase in speed as well as display the signal strength, or locked, when the satellite is found. Background signal strength is measured on the left bar, which can see all satellites. The right bar will show the actual signal strength of the connecting satellite. Slowly sweep the sky by moving the dish azimuth by hand. If you do not find the satellite on the first sweep, lower or raise the dish 1 degree closer to where you believe the satellite is located. Sweeping patterns of 1 degree increments assure that you will eventually find the satellite. This process takes time and patience. Move the dish slow enough so that the SuperBuddy has time to process that the signal has been found. Both the display and quick beeping will alert when the signal is found. However, the pointing process is really just beginning. To turn off the beeping, press the speaker button. Now confirm the skew angle is as precise as possible. Also move the azimuth fine adjust nuts so that they are lightly secured on both sides of the limiter to keep the system from traveling. Once the satellite is found, the next step is to find the direct center of the signal. To do this, we find the edges of where the satellite signal drops off on either side of the azimuth axis. Open up the azimuth fine-tuning nuts to create a small area of travel. Carefully watch the SuperBuddy for when the signal drops off on each side and move the azimuth nuts to the 2 locations. Once both positions are found, position the dish to the center of play and then finger tighten the nuts to lock them in. Finding the elevation center is done in a similar fashion. Find the signal edges and then place elevation between the 2. With both azimuth and elevation centers found, the dish is fairly well aligned. The signal reading on the SuperBuddy should reflect the highest reading as well. To peak the skew axis, the right meter reading is used. Simply rotate the skew for the highest possible reading. The high-grade built-in RG6 coax cable is used for this installation. The first step is to cut 2 cables of equal length to the distance desired. Cable lengths must always be under 150 feet. Clamp a coax stripper to the end of the cable. Spinning the stripper several times around the cable will make 2 clean cuts. Pull the stripper away from the coax to remove the coax sleeves. Note the 2 cuts the stripper makes on the cable. Practice these cuts to become proficient in using the stripper. The stripper has 2 adjusting Allen screws that control the height of the 2 cutting blades. Note the Allen wrench is also included. Once the cable is stripped, peel back the braiding of the coax. RG6 snap connectors come in 2 pieces. Insert the blue sleeve first over the coax with the fat side of the sleeve first. Now thread the connector and firmly twist the coax inside. The white shielding should be seen on the back of the connector opening. Now slide the sleeve into the connector and insert the cable end inside of the compression tool as shown. Gently squeeze the compression tool and snap the sleeve into place. Cut any excess wire so that it protrudes about 1/8 of an inch from the connector end. Mark both ends of a single cable with the same color using electrical tape or tie straps, red for the transmit cable and blue for the receive cable. Now we are ready to connect the high-grade coax cable to the LNB receiver using the supplied water-resistant connector. The first fitting contains a rubber O-ring used to make a water-resistant seal. Now attach and twist on the cable. Screw it on as far as possible. And use an open-end wrench to tighten the fitting a bit more. Do not over-tighten this connection or you may damage the LNB. Tighten the O-ring connector against the cable connector to complete the seal. Now cut off a short segment of rubber tape and peel off the white plastic backing. Stretch the rubber tape as close to the LNB as possible to cover all exposed metal. and then tightly wind the tape around the connector to create an excellent waterproof seal. Cover the entire connector, including part of the coax. To keep the rubber from breaking down in the direct sun, wind electrical tape over the rubber tape. The connector is now sealed and protected from the weather. The process is again repeated with the transmission coax connector. Keep cable runs to 150 feet from the satellite dish to the indoor unit. Also make sure to bundle a few extra feet of coax at the base of the satellite dish for any unforeseen requirements. Make sure to use tie straps liberally with all of your installations to keep them looking professional. The iDirect satellite router or gateway is where both coax cables will connect. LEDs on the front of the unit show system status. On the back of the gateway, connect the red transmit cable to the TX out connector and the blue receive cable to the RX in connector. Now plug the AC-DC power adapter into the gateway. There is no power switch on the iDirect modem, and the unit will turn on whenever power is available. LED lights on the back of the gateway show system power, transmitter power, which simply means voltage is present to the transmitter, and LNB power, which means voltage is present to the LNB. Boot time for an iDirect modem is just over a minute. On a typical boot up, a blinking status light shows the unit is performing a self-test before loading the operating system, which takes about 60 seconds. The RX LED shows LNB receiver status, the TX LED shows the transmitter status, net shows if there is a network connection established, and status shows the overall system state. When the RX LED is green, it means the router is receiving a signal. A dark TX LED means the transmitter is not yet enabled for normal transmission. Net is blinking amber because a network connection has not been established. This status display of RX green and TX dark is typical of what an installer will see prior to calling the NOC for a final cross-pull and activation of the satellite link. If the RX LED is blinking amber, there is one of three problems. The receive coax cable is disconnected, or the dish is not pointed correctly, or the iDirect configuration is not valid. If this is the case, check your cables and make sure the dish is pointed correctly before calling support. On the back of the gateway, if there is a red LED on buck power or LNB power, there is a short in the receive or transmit cable. Prior to calling the NOC to activate the link, we need to run the iSight program to access the iDirect gateway. Plug in a crossover Ethernet cable into the computer. The X on this cable denotes crossover, which is an Ethernet cable that allows for a direct connection between the gateway and a laptop computer. Plug the crossover into the LAN A port of the iDirect gateway. The laptop network settings will need to be configured in order to communicate with the gateway. This information can be found on the LAN setup section of the customer sheet. In Windows 7, open up the control panel and double-click on Network and Sharing Center. Locate and click on Change Adapter Settings, and then select Local Area Connection. On the Properties window, double-click on the Internet Protocol version 4 to open the configuration window. For Windows XP, double-click on Network Connections from the control panel, and then right-click on the Local Area Connection to select Properties. On the next window, double-click on the Internet Protocol TCP/IP. The network configuration screen is identical for both XP and Windows 7. First click on the Use the following IP address and fill in the boxes using the information from the customer information sheet. The connection should now be established. From the CD-ROM, open the iSight folder and then double-click on the iSight program. When it runs, it will attempt to locate and connect to an iDirect gateway, which will appear on the top right-hand corner. Right-click on the gateway and then select Login. On the Login window, click on the Admin Radio button and enter in the default gateway IP address. The password is capital P, the @ 55, lowercase w, 0, lowercase r, lowercase d, exclamation point. Press Enter or OK to bring up the iSight status window. Select Configure from the menu option, then Align Antenna, then Cross Polarization. The Cross Polarization window will appear. Once this window is open, the installer may contact the NOC for system activation. When speaking with the NOC, make sure to have your customer information sheet available. They will ask you for the modem serial number and the circuit ID. The NOC is able to see the connection strength of the installed satellite system. Normally, they will ask for slight adjustments to the skew to see how well the system was pointed. Sometimes they will ask to move the azimuth or elevation slightly, but this is the exception to the rule. The NOC will ask you to enter a frequency on the cross-polarization window open on the computer. They may also ask you to adjust the transmission power up or down. Pressing the up or down arrows will adjust the signal strength by half a decibel meter. Press Start only when asked by the NOC to start the cross-polarization test. Never press without permission. Also, press Stop only when requested by the NOC technician to finish the session. At some point, the NOC technician will give you the go-ahead to lock it down, which means tighten the bolts on the skew. Once the NOC sees the system is stable, they will activate the link and normally end the call. Of course, now is the time to tighten everything else down. Make sure to tighten the azimuth pivot bolt, the elevation pivot bolt, the azimuth adjustment nuts, being careful not to move the dish, the top elevation adjustment nut, since the bottom nut is under pressure, as well as any other bolts on the entire satellite system. Take your time and make sure that everything is fully tightened. To confirm the link is active, all 5 of the gateway LED lights should be a solid green. You can test the link by doing a ping test, such as to the primary DNS address. Or you may simply open up a browser and pull up any website address. We certainly hope this installation video has removed some of the mystery of installing a larger satellite system. Know that if you run into problems, Ground Control is always here to support you 24/7.